Hey everyone, and welcome to The Explainer. Today we are shining a massive spotlight on the ultimate unsung hero of your home. You know what I'm talking about, right? The very thing standing between you and absolute, sweaty misery when the weather turns extreme. Yup, your HVAC system. We usually completely ignore it until it suddenly breaks down, but today we're going to understand exactly what it takes to keep it alive and kicking. To do this, we're using the city of Noblesville, Indiana as our perfect microcosm. It's a place where the climate puts systems through an absolute torture test, which makes it the perfect classroom for understanding this universal struggle. Okay, let's dive into this survival plan. We'll cover 1. The climate comfort battle, 2. Anatomy of a breakdown, 3. The secret to system survival, 4. The science of sizing, and 5. The 5,000 rule.
Section 1. The Climate Comfort Battle.
So, to really grasp how to maintain your equipment, we first have to understand the relentless war of attrition happening right outside your walls. Imagine living in what experts call the humid continental climate zone. Think about those intense seasonal swings. In the summer, you're dealing with mid-90s heat combined with this absolutely suffocating humidity. It makes your air conditioner run non-stop, just gasping to keep the air dry and cool. Then flip the script. In the winter, the temperature plummets to sub-zero, staying freezing for weeks at a time. Your furnace has to cycle constantly just to keep you from freezing. Your system literally never gets a break. And honestly, it's not even just the extremes. Spring and fall bring these rapid temperature changes that force your equipment to short cycle, wearing out components so much faster than they would in a milder climate.
And it's not just the temperature either. Local geography actively plots against your home's comfort. And this brilliantly illustrates what I mean. Looking at our Noblesville example, you've got the White River and nearby reservoirs creating these microclimates that trap moisture. That stresses cooling systems and actually promotes mold growth right inside your ductwork. Then, look down at the dirt. The clay-heavy soil common in Hamilton County holds water right up against foundations. That causes basement HVAC equipment to rust and corrode way faster than units on upper floors. Add in older homes with settling foundations that literally pull the ductwork apart, and you can see how the environment itself is the true enemy here.
Section 2. Anatomy of a breakdown. Well, when your equipment is locked in this intense battle with the elements, predictable failures are going to happen. Let's clear up some industry jargon real quick. Ever heard a technician mention a capacitor? Think of it like your system's starter pistol. It's a little electrical component that delivers a massive, crucial jolt of starting voltage to get your compressor and fan motors running. But because of the severe heat stress and those electrical voltage spikes we just talked about, these capacitors fail all the time. When they do, it is game over for starting the system. You might hear the motors humming, desperately trying to start, but without that pistol firing, they're just not going to spin.
Now, a capacitor is a relatively easy fix. Let's look at something far more devastating, the heat exchanger in your furnace. Here is exactly how it breaks down. Step 1, the metal expands when it gets hot. Step 2, it contracts when it cools down. Step 3, after years of this relentless temperature cycling, those expansions and contractions create microscopic stress fractures in the metal. And Step 4, the truly terrifying part, those cracks can leak dangerous, invisible carbon monoxide directly into your home's air supply. This usually happens after 15 to 20 years of service, and make absolutely no mistake, a cracked heat exchanger is an automatic death sentence for the furnace.
Section 3. The secret to system survival.
Okay, I know that sounds incredibly grim, but don't worry, we do have a defense strategy. So the crucial point is right here. Look at the dramatic difference in lifespan. A neglected system might only limp along for 10 to 12 years before the elements completely destroy it. But a well-maintained system, you're looking at 15 to 20 solid years of life. Why? Because annual checkups act exactly like an annual physical for your house. A technician catches the small things, like testing that starter pistol capacitor we talked about, and replaces it before it fails and permanently damages your vastly more expensive compressor motor.
And hey, if you think skipping maintenance saves you money, consider this massive number: 25%. That is the staggering drop in system efficiency caused simply by having dirty coils. Neglecting your system literally wastes your money every single month on your energy bill. A basic annual maintenance visit easily prevents that loss. It's a no-brainer.
And while we're on the subject of massive energy waste, let me share a huge insider secret about ductwork. Most homeowners have no idea that flexible ductwork in attics and crawl spaces just separates over time. These leaks waste an unbelievable 20 to 40% of your system's output. That forces the equipment to run longer and harder just to cool the house. But here is the real secret. Despite its name, ordinary cloth duct tape is actually the absolute worst thing you can use to seal these leaks. The adhesive dries out and completely fails within months.
True professional survival means sealing those leaks with liquid mastic and permanent metal-backed tape.
Section 4. The science of sizing.
Of course, even the absolute best maintenance plan can't fix a system that was doomed from the start. Survival actually begins on day one with an industry term every homeowner should know: Manual J. Now, what's really interesting here is that this is a highly scientific load calculation. It doesn't just lazily look at the square footage of your house. It analyzes your insulation levels, the size and direction of your windows, how much air leaks through your walls, and specific local climate data. Guessing what size unit you need based purely on square footage leads to total failure. An undersized unit will run constantly and die young, while an oversized unit will short cycle, completely failing to dehumidify the air. Manual J is literally the exact science of comfort.
And let me tell you, the contrast between a cheap, corner-cutting install and a true professional installation is massive. A bad install just guesses the size, a pro uses a Manual J load calculation. A bad install slaps on cheap cloth tape, a pro uses mastic and metal tape. But you really got to look at the refrigerant row. A bad installer will just guess the refrigerant charge. A professional installer, complying with rigid Indiana mechanical codes for instance, will perform a 400 psi pressure test for a full 24 hours to ensure there are absolutely zero leaks before charging the system to factory specifications. A quality install definitely costs a bit more upfront, but it adds years to the equipment's life.
It all comes down to precise standards, like Manual D for your ductwork. Proper duct design isn't just about moving air around, it is all about speed. Ducts must maintain an airflow velocity of 600 to 900 feet per minute. If the ducts are too small, the friction literally kills the airflow. If they are too large, the air velocity completely drops off and the system basically can't breathe at all.
Section 5. The 5,000 Rule.
So, we've covered the climate, the breakdowns, the maintenance, and the installation. But at some point, the battle ends, right? The equipment just wears out. So how do you know when your system is truly dead? When is it time to stop throwing your hard-earned money at repairs and finally replace the unit? Well, industry insiders actually use a very specific mathematical formula for this exact moment.
It's called the $5,000 rule. You take the age of your system and multiply it by the estimated cost of the repair. If that total number is greater than $5,000, it makes total financial sense to just replace the unit. For example, let's say you have a 15-year-old air conditioner and your technician quotes you a $400 repair. 15 times 400 equals $6,000. That is over the $5,000 threshold, which creates this instant, undeniable aha moment. It tells you the system is losing efficiency fast, and that $400 is way better spent on a new, high-efficiency system rather than slapping a Band-Aid on a dying machine.
Let's move on and see how this builds into real-world financial clarity. For a typical 2,000 square foot home, an initial diagnostic service call usually runs somewhere between $75 and $150. Now, if you do hit that $5,000 rule threshold, a full system replacement is going to be an investment of roughly $6,500 to $10,000. But keep this in mind. Having good insulation and perfectly sealed ducts, the very things we've been talking about, are exactly what keep you on the lower end of that replacement cost spectrum. They allow you to buy a smaller, much more efficient system. We've covered a ton of ground today, from the intense heat and freezing winters that constantly wage war on your home, to the exact, precise science of keeping your system alive. So I want to leave you with this final, truly critical thought. If your HVAC system is the beating heart of your home, battling the elements every single day, is your current maintenance plan actually setting it up to survive, or is it setting it up to fail? Armed with this insider knowledge, you are now equipped to make the absolute right choices to protect both your comfort and your wallet. Thank you so much for learning with us today on The Explainer.